Hey there, everyone. In this video, I want to give you a quick introduction to continuous probability distributions, which are probability distributions that correspond to a continuous random variable. So the idea is that we have a random variable, x, and that random variable, it's not discrete, so it can take on any value inside some interval. And I don't know, some examples of that might be something like, let's say every day you're going to go outside and record the temperature at, say, noon. So we'll let x be the temperature at noon. Well, let's say on your balcony. Now that value can be any number between some kind of reasonable range. Like, I don't know, maybe if you live in San Francisco, it never really gets colder than 30 degrees. It never even gets to be 30 degrees. And it never gets to be certainly not more than 100 degrees. So x could be any value between 30 and 100. Now, when I say any value, I mean truly any value, right? You could record the temperature one day and it'd be 55 degrees. And maybe you go the next day and it's 55.2 degrees. And maybe the next day you get 63.1 degrees. Or if you really had an accurate thermometer, you could do things like measure 65.273 degrees, right? Any number in this interval from 30 to 100 is possible. And there's lots of numbers in there, not just the whole numbers, right? Bazillions of numbers, really infinitely many numbers. So when we say any, we really mean any. But we know that it's not equally likely, especially in San Francisco, that you're the same likelihood of measuring 30 degrees as it is measuring 70 degrees, right? So that's why we have a probability distribution to describe the likelihood of all these temperatures relative to one another. I'm going to describe this by drawing a graph. And maybe it looks something like this. So here I've got this curve. It is describing the probabilities of these different temperatures that might be measured outside on your balcony in San Francisco. There's very low probability of measuring something like 30 or 40 degrees in the city, and also very low probability of measuring something in the high 90s. And there's pretty high probability of measuring something in the 60 to 70 range, and probably I should have made that more like 50 to 60 range being the most likely, but this is just an example. And it's also fairly likely that you get something in the 80s, but not as likely as getting something in the 60s. So this is how we read these kinds of graphs. And that's all they're really supposed to tell us. Once we have a probability distribution for a random variable, we can do lots of stuff with it, like compute probabilities of the measurement being between two values or above a certain value or below it. And the way that we characterize probability in a graph like this, the thing that is intended to represent is probability corresponding to area. So for continuous random variables, probability equals area. So that means that, say, we were interested in the probability of the temperature being between 60 and 70 degrees when we measure it, is exactly the area that's in that region between 60 and 70. So we would find that probability by blocking off this portion of the area underneath the probability curve and finding its area. So the notation for that I should also include here is that we're looking at the probability that x is bigger than 60 but less than 70. And if we can figure out what that area is, then we will know the probability of that random variable being found to be in the interval from 60 to 70. So one of the important things about this way of visualizing probability distributions for continuous random variables is that we have to make this assumption. If we're going to interpret area as probability, we have to make sure that everything makes sense. And one way we're going to do that is by assuming that the whole area is equal to 1. So in this case, where we're talking about the probability distribution being between 30 and 100, that's the same thing as saying the probability that x is between these extreme values that describe the bounds. That's 1 or 100%. Okay, so that's a quick start to the idea of a continuous probability distribution. In the next video, you're going to learn about the uniform probability distribution, and we'll go through some stuff and reinforce this and actually do some computations. But for now, I think this is enough of the story to get you started.